welcome one and all. Happy holidays. Merry Christmas. I bring you dread tidings from the Dark Lord Cthulhu. For I, as ever, am Alhaz Red, and I'm here to teach you the eldritch magics, the dark arts of cyber security. And I'm here in that most hallowed and cherished of holiday traditions for TryHackMe's Advent of Cyber event 2021. And we're going to be walking through day 9 of Advent of Cyber, which involves packet analysis in Wireshark and what forbidden knowledge, what maddening revelations can be gleaned by looking at the raw packets that are flying across the network. And we're going to find there's quite a bit that can be found, my friends. And I'm so excited. I can feel right through this video, through the screen, I can feel that your hearts are open, your brains are smooth, and you are ready to gain more knowledge, to gain more brain wrinkles. Because truthfully, especially in cybersecurity, it's not about where you are. It's not about your current level of knowledge, because we're all at varying places in our level of knowledge. It's about where you're going. It's about constantly learning more. So today, we're going to add a few more wrinkles to that brain. We're going to add some more knowledge, and we're going to expand our minds. We're going to open our eyes a little bit, and let's just hop into it. Let's get going. I'm excited. So here we are in the Advent of Cyber event. You see that I have the attack box open on the right. If you'd like to follow along with this video, you're going to want to start up the attack box. And if you don't know how to do that, just come on up here. There'll be a button up here that says attack box. Let that start up. It's going to open a window right on the side like this. And that'll get you started. That'll get you going. Now, we're going to be using, for our purposes today, a tool called Wireshark. Okay, a tool called Wireshark, which is what's called it has various names: a packet sniffer, a packet analyzer. Okay, but what are we specifically talking about when we see packet analysis? Let's see what we have, what TryHackMe recommends. So packet analysis is a technique used to capture and intercept network traffic that passes a computer's network interfaces. Excuse me. So basically, you're just recording the raw bits and bytes of network communications that are flying across a computer's network interface, and you're recording them in a packet capture file, in typically a .pcap or PCAP file. And that's what we're going to look at today. We're not actually going to capture any packets, but we're going to analyze a packet capture that has already been made for us. And we're going to do that using a tool called Wireshark, which is a common open source tool for this. I recommend the attack box because Wireshark is already installed on that. If you need to install Wireshark, you can download it right here with this link. If you decide to go that route, you're also going to need to download the packet capture file by clicking on this link, which is going to allow you to download it. If you're on the attack box, Wireshark and the packet capture file are already there and ready to go. So let's just start it off by opening up the terminal. Okay, open up our terminal here, and we're going to type in sudo Wireshark, and we're going to give the path to the file. Oh, it's AOC3 day 9 AOC3.pcap. Okay. Now, some of you, I can feel again. Using my powers of red teamer perception. Okay, I can already tell that some people on the other end are like, Mr. Streamer, why do you need this sudo when you're clearly running as root? Because according to this pound symbol. I'm like, yeah. So in the attack box, you are already running as root. So this sudo is unnecessary. It is superfluous and unnecessary. However, some people may not be using the attack box or may not be running as root for whatever reason. And I'm doing this to highlight the fact that Wireshark does need to be run as root. Most packet analyzers are going to need to run as root because you need to be root to analyze network to capture packets on a network interface. Wireshark is not the only one of these, obviously. Others include T-Shark, which is actually Wireshark's command line variant. There's also TCP dump, which is built in to most Linux machines. There's also Python's Scapy library, many others. Okay, there's many of these. But Wireshark is one of the most common and well-known. So that's what we're going to be using today. Let's go ahead and hit enter. Let Wireshark start. And it's going to open up. And right off the bat, before we even touch anything, before we look at any of this, you're going to see there's a lot of information flying at you. And your brains are going to have a tendency to turn off. Just because, look at what we got here. We got all these buttons. Who knows what all this crap does? And then we have these numbers here. We've got some garbled mess here. And then we have what appears to be eldritch runes inscribed on the walls of R'lyeh, or some ancient city by some long dead race that predates humanity. Down here, what is even going on? What's happening in this paint? Don't worry, okay? Don't worry. Al's got you, okay? I'm gonna grip you tight and lead you through this gauntlet. These unknown eldritch paths, okay? So follow along with me. Let's take it step by step. Let's talk about each section of the pane that is presented before us, okay? Right up at the top, you got your standard drop-down menus. There's obviously today we're only going to be scratching the surface of what Wireshark has to offer. We're talking like the tip of the iceberg. But I'm going to be encouraging you several times today to explore around in Wireshark. Okay, explore, get your feet wet, play around, see what you can get up to. That's where the real learning occurs. Okay, playing around, tinkering. But for right now, let me draw your attention to the file menu. You could have used this open to open a packet capture file. You can also export a packet capture file or even export files contained within the packet capture file. For example, if you captured a file transfer of some kind, you could literally export the file to your local machine from the packet capture file, which is pretty neat. Over here in the capture menu, you see a way to start the interface, and if the interface was started, you'd see the ability to stop and restart. You'd see the ability to apply filters to the interface. You'd see the ability to refresh them, and so on and so forth. God, I think my cat closed the door on herself. That little goofball, of course, while I'm recording. So that's all I want to draw your attention to up here. The next part that I want to point out is this display filter right here. Now, this is going to be one of the most important things that we talk about today. We're going to get to that here in just a second, but for right now, just know that it's there. This is where we're going to filter the packets down here so that we can see the ones that are of particular interest to us. And I'm going to show you just how to get started in doing that. So here is the list of packets. Now, let me go ahead and make this a little bit. Let's get a good look at this list of packets. So you can see, there's a number of columns. Each one of these rows is a packet, okay? Is a packet that was captured. And you can see that you have number, which is a sequential number of the packets that have been captured. And if you scroll all the way down, you'll see that there are 5,208 packets, which is actually not very many packets at all, if you'll believe me on this. Anyone who's ever captured packets on a network of any kind of size with any kind of traffic going over it, if you've ever captured packets on a router or a switch, you're going to find that in minutes you could have hundreds of thousands, or even in millions of packets, depending on the size of the network. This is a fairly small packet capture, all things considered, but still a lot of packets. So going back to the filters, we're going to want to find a way to pare this down. And only see the packets that we really are interested in, okay? You can also see the time in seconds. This packet capture ran for about 1,445 seconds before it was stopped. You could see the time that the relative time from when the capture was started, when the packet came in. You can see the source IP address, the destination IP address, the protocol, and then you can see the length of the packet and then some info about it. Okay, so that's basically what we're looking at in this packet list pane. Now down here, this is the packet details pane, where you can see information about the individual packet itself. Now, similarly to with not going into Wireshark's full bevy of functions, I'm going to kind of be skipping over or basically assuming that you have at least a basic understanding of things like the TCP handshake, the OSI model, networking in general. If you don't, that's okay. I think that you're still going to be able to get plenty of information from this regardless, but especially in this pane, you'll understand a little bit more if you know something about the OSI model. This is not the proper venue to be going into the very extensive and complicated subject that is networking. But if you already have a little bit of a background in that, you'll understand a little bit more of what's going down here, right here. Now down here, what you see is the raw content of the packet itself. Now, you wonder why it's in these odd eldritch runes. That is actually hexadecimal. Now, keep in mind that every one of these packets ultimately is just electrical impulses. It's bits and bytes, ones and zeros that are being transmitted over a network. And one of the best ways to represent, one of the most convenient ways, I should say, to represent binary data like this is through hexadecimal. So sometimes it can be valuable to see the hex that makes the raw hex, the raw binary that makes up the packet. And you see that some of these characters just happen to correspond with ASCII. And especially when we get into like some of the clear text protocols like HTTP and FTP and so on, what you're going to see is that that some of this hex is actually readable because it's just ASCII. It's just ASCII characters. This hex is not readable because this is actually an RDP packet. You can tell by the port that it is coming from here. This is actually a remote desktop protocol packet, and those are encrypted. So this is actually encrypted data that you're not. That's why it's just a garbled mess. So this particular pane is not going to be of too much interest to us, but you will see that when we get into the clear text protocols, they become much more readable. Now going back to let's start really delving into analyzing these packets, okay? Let's get into it, okay? The first thing we're going to want to learn, and we're going to be continuously learning throughout this video, is filters, the value of filters, okay? There are multiple ways to filter packets. You can either filter them pre-capture, as in you can filter which packets you capture in the first place, or you could just capture all the packets and filter the ones that you have, which is what we're going to do here. Okay? We're going to be this is an already captured PCAP file that we're reading from disk, and we're going to be applying filters using Wireshark syntax to only see the packets that are of specific interest to us. So let's talk about that. Let's talk about it, okay? So just glancing at this, I can see that one of the IP addresses in question here is 10.10.10.6. Now let's say that, hypothetically, we wanted to isolate only the packets that involve that IP address, that either come from or are destined for that IP address. The way you're going to do that is by typing ip.addr, and you see that Wireshark very helpfully tries to assist you in that, in creating these filters. And you notice that we type in ip.addr, it goes 10.10.10.6. Wireshark will highlight the filter in green if the syntax is correct, which is very helpful to us. And we can see here that we have that we have all packets that either start from or go to 10.10.10.6. And we see that there's an SSH session, which, as you can see, is encrypted. This is encrypted because SSH, Secure Shell, is encrypted. But we also see there's we could probably go ahead and filter this even more if we wanted to, but this is only a demonstration. We'll get into it. We also see some HTTP traffic, and we see that there is some readable data over here. So not all of this stuff is encrypted, okay? Which is going to be very useful to us going forward. Now, let's say we just wanted to see the HTTP traffic. How would we do that? Well, it turns out that's very easy. We could just type in HTTP. And sure enough, we get all of the traffic with the protocol HTTP. Isn't that nice? How useful, how truly useful. Now, if we wanted to, for example, if we wanted to, let's say we only wanted to see HTTP traffic that involved 10.10.10.6, can we combine both filters? Why, yes. I'm glad you asked. And ip.addr equals. Remember, there's two equals signs there. One equal sign will not do it. And now we're seeing only HTTP traffic to or from 10.10.10.6. And you can use this to chain together an indefinite number of filters if you so choose. This is very, very, very useful. Now, we did mention the presence of some of these pesky RDP packets. Now, these are all just gibberish packets. They're not ever going to be of any use to us. RDP is remote desktop, and it appears that whoever was taking this packet capture did so by remote desktoping in somewhere else. So we have all this useless data in here because we're not really interested in this remote desktop session. But let's talk about how to isolate it. Because it doesn't say, it just says protocol TCP. It doesn't say RDP. So what you can do is tcp.port equals remote desktops port, which is 3389. And we have isolated all of the packets that have to do with that RDP session. And we can see down here at the bottom, if you're paying attention, that it actually tells us how many packets are currently displayed. 2,195 packets. So almost half, 42.1% of this full capture is just remote desktop. That's very unwieldy. Again, we want to pare down this capture as much as possible so we have as little as possible to look at. We don't want to just sit here and go through every single packet. We want to only see the interesting stuff, and RDP is just not going to be interesting to us. So to do all the packets that are not RDP, all we have to do is put not before that, and boom, RDP is completely gone. And you see down here, displayed 3013, 57.9, all of the packets that are not RDP are currently displayed. And we see a lot more interesting stuff here, a lot more interesting things happening. Yeah, so great, fantastic. Now, let's talk about HTTP in particular. That's why we're up here, right? So if you want to look at, as we said, let's just filter for HTTP. Okay. Now let's take a look at this. Let's see what we can glean from one of these HTTP packets. Okay. Let's pick, for no particular reason, this guy right here. And let us... And also take note that, by the way, when you look down at this raw packet down here, the raw packet contents down here, you can actually see that some of it is, that quite a bit of it is readable now. And that's because this is a clear text protocol. So a lot of these hexadecimal characters are going to be ASCII now. So yeah, again, this is not terribly useful to us, but I just wanted to point that out. Let's open up this hypertext transfer protocol subtree here. Let's just open that up, see what it contains. So here we can see some of the HTTP headers, such as the user agent, which is the user agent by the client that is accessing the web server. And what we notice is, I want you to take note of this user agent, Go HTTP client. My goodness, that's quite interesting. So typically, if you just as we'll see in other packets as that we're going to look at here in a little bit, the user agent is sort of a fingerprint of the device that is accessing the web server. In this case, this appears to be an automated script in Go, using the Go HTTP client. And you see that if you look at subsequent requests, we see it's looking for /admin, /login, /www, /cpanel, /cess, /include. And most of these are returning 404 not found. So the astute among you may have already figured out where I'm going with this. This is Go HTTP client. It is very likely that the tool, that what you're looking at is the resulting packet of this tool, GoBuster, which is a directory brute force tool, similar to Dirbuster, which you experienced if you've been doing this day by day. One of the previous days involved directory brute forcing on a web server using Dirbuster. You could have also used GoBuster to do that. It's basically an equivalent tool. What we're seeing is what that looks like, what GoBuster looks like on the network. How interesting. Isn't it? It's how fascinating. How do I get Wireshark back open here? Here we go. There we go. Right there. All right. And what is notable about this? Well, we see that we have 10.10.10.4 that's making all these GET requests using what appears to be GoBuster, an automated not a script, but an automated program that's trying to browse for all these things. So 10.10.10.4 may be a malicious actor that is trying to enumerate a web server on 10.10.10.6. So we would then want to filter for other packets from 10.10.10.4. That may be an adversary IP address, or it may be a compromised IP address. A lot of times adversaries, hackers, like to launch their attacks from previously compromised machines to obfuscate the source of the attack. That may be what we're seeing here. Again, packet analysis is very similar to you're solving a mystery. You're like Sherlock Holmes. You're looking at all of these different clues and putting together the mystery, the grand mystery of what went down on this network. By looking at things like this. So this is pretty neat. We're seeing a GoBuster scan here, and that's pretty cool, right? That's pretty cool. So going back to the object of the day, which is to answer these questions, we're going to look for which one of these directories returned a 200 OK response. Okay. Which ones of these returned a 200 OKs? Because we see that it browsed for /admin and got a 404 not found.
Can't let you do that, Star Fox.
It got a 404 not found. Can't get into /admin. Feels bad, man. So instead, but we do see that when it browsed to /login, when it browsed to /login, it got a 200 OK. And if you double click on the packet, by the way, you can open it up and see the whole thing. You got a 200 OK. So the directory that it's looking for is login. Go ahead and submit that. Great. Fantastic. Awesome. So when you're thinking HTTP, when you're thinking clear text protocols, okay, when you're thinking clear text protocols in a packet capture such as HTTP, the first thing you should be thinking is, of course,
a fine addition to my collection.
That's right. We're looking for credentials, fine additions to our collection. General Grievous is always looking to add lightsabers to his collection, and we're looking, credentials are our lightsabers. We want credentials. Now, when you're looking for credentials, more often than not, they're going to be found in post requests. If you remember from one of the previous Advent of Cyber challenges, you talked about GET and POST requests. GET requests are typically used to receive information, for your web browser to receive information from a web server. POST requests are used to push data to the web server, such as your login credentials to be evaluated by the web server. So typically, logins will take place during using post requests. So what we find here is a post request right here. But if we wanted to filter for post requests, we could do HTTP request dot method equals post, and we can see some post requests here, and we can come down here and we see that the information that we want is actually here. It is actually here. It's in this file. It's in this file data down here. But this is not really. This still isn't really ideal. And at the risk of sounding like an infomercial, there's got to be a better way. And there is, Kevin. And we're just going to come in here. We're going to go to follow. And you can either choose TCP stream or HTTP stream. When it comes to HTTP traffic, typically HTTP stream will be more readable and useful for you. TCP stream is still going to contain some of that extraneous TCP binary data we don't really care about. So let's go ahead and click on that. Also, there's probably someone named Kevin out there who's like, how does he know? I just have that power, my dude. I just have that power. So here we are. As you can see, now that we're following, now Wireshark has now done the brute work of us for us of putting together this HTTP stream for us, of putting together this stream of HTTP requests and responses. We see a flag down here that maybe was used in a previous challenge or in a future challenge or a different challenge, regardless. But that's not one of our flags today, I don't think. If we go back up, we can see this original post request to login.php. If we go down here to the post data, we can see a username and a password here. Splendid!
A fine addition to my collection.
A fine addition to our collection indeed, General. So let's go ahead and copy the username. Let's paste that in. Let's do a colon separator. Now, if you can't tell if it's going to be a colon separator, it gives you the basic format right here. You could have also clicked on the hint to see that. But that's how you get that, to know that there's a colon separator. And then we're going to copy this password right here. Put this in. And yikes.
Can't let you do that, Star Fox.
Please! God damn it! Hate this hacker crap.
So we didn't get that one. We didn't get it. Why didn't we get it? Well, the astute among you already know the answer. Because this last %21 is not part of the password. Really. It is, but it's not. Yes, but actually no. So this is what's called URL encoding. So typically when your browser makes an HTTP request, some of the characters are not great. Some of the characters are encoded to make sure that they're interpreted the correct way on the other end, putting it simply. So we just simply need to decode this. And a simple way to do this, there's plenty of things online that allow you to do this. So let's head on over to the best hacking tool, any search engine that you'd like. We'll just use Google for today. URL decode online will work just fine. You could also use CyberChef for this. Paste this in here. We decode, and we do see it's an. If we can zoom in, it turns out that %21 is the URL encoded form of the exclamation point. Great, fantastic. We've cracked the code, and we've gained a few more brain wrinkles as a result. Let's go ahead and submit, and boom, we get it. Okay, so be cognizant of that when you're dealing with HTTP requests, that oftentimes you're going to have characters that are URL encoded, and get into the habit of spotting that. Okay. Now, as far as the next question, what is the user agent's name that's been sent in HTTP number 2 post section? That is this user agent right here. As you saw that we used the user agent to devise what a GoBuster scan looked like earlier. And this time we're using it to read a flag. There we go. I'm feeling great, my friends. We've already we've already found some fine additions to our collection. We've had we've already made great strides on this challenge. I'm feeling real good. Let's do a whole new protocol now. Let's do DNS, domain name system. If you scroll through here, you will see some DNS requests. I just saw one in blue, but yeah, they're in blue right here. DNS requests. If we want to filter for DNS, well, immediately the astute among you are saying port 53, right? So TCP.port equals 53. And yikes, Al! There are no packets. We just saw DNS. But remember, my friends, the majority of DNS traffic, and yes, I do mean the majority and not all, is on port 53, but it's UDP. Let's remember that your standard DNS requests and responses are going to be sent on port on UDP, which is an entirely different protocol. There are DNS packets that are sent over TCP, but when we're doing that, we're talking about zone transfers and that kind of a thing, which is a different discussion entirely. Right now, there are no zone transfers taking place over this network. So UDP port 53 will suit us just fine. Now, when we look at UDP, let's take a look at some of these. Let's go ahead and click on this first A record request right here. Let's click on domain name system. Let's make this a little bit bigger so we can see. And we can see some information that I want to call your attention to. So here we see the questions field says 1. That means there's one query contained within here. That's pretty standard. We come down, we can expand the queries subtree to see what actually is being queried for. This client is looking for the IP. Keep in mind what DNS does, what domain name system is meant to do. This is how your browser, humans don't remember IP addresses very well. We're not good with numbers, okay? Our primitive ape brains cannot wrap around the advanced giga, cannot wrap around the giga advanced language of numbers very well. Not good at it. Okay, so we have an entire system, domain name system, that is used to translate words into numbers. When you type in www.google.com or packet.tryhackme.com and hit enter in your browser, what's actually happening in the background is your browser is sending a DNS request because it doesn't know what packet.tryhackme.com is usually, unless there's caching or something like that, but that's outside of the scope of this discussion. So it's going to send a DNS request to find out what IP address corresponds to this domain name. Okay? That's what is being requested here. All right? So if we want to see the response, if we want to see the DNS response, I want to draw your attention to this transaction ID right here. So typically every DNS server is answering a lot of DNS requests. It's handling a whole bunch of DNS requests all at the same time. They basically are how the internet works. Like in simple terms, they're basically how the internet works. So there's a lot going on for a DNS server at any given time. So each transaction is going to be given an ID, a transaction ID in hexadecimal. So that's used to keep track of the particular request. And if you just look at the next packet here, you see that same transaction ID is included here. This is their response right here. But what if this wasn't the next thing in the packet? What if this was what if this was a much more loaded network with a lot more DNS requests happening? And what if this response came sometime later for some reason? How would we find it? Well, once again, we can use filters. Again, filters. Learn Wireshark filters. If you're going to spend any time in Wireshark, you're going to have to spend time in this filter bar, okay? The DNS DNS.id is going to give you, and then you just type in the transaction ID you want, which is 0xF263. Okay? And you see both of those packets, the request and then the response, right there for you. Okay? Does that make sense? Fantastic. I heard you all say okay. You all understand. Fantastic. So we look at the response. We see that there now is an answers section down here, and we can expand that, and we can see that it's responding and saying, hey, packet.tryhackme.com is located at address 127 001. Spectacular. Splendid. So we now know how to basically read these DNS requests. Well, this question throws a little bit of a curveball at you. There is in the DNS section, there is a text DNS query. A text record is another kind of DNS record. Right here, what we're seeing is a type A DNS record, which is a different type of record. That's probably the most common type you're going to see. But a text record also exists. And we want to find that particular record, which is a little bit unfortunate because, and by the way, you can't just use DNS to see all of the DNS packets. Because again, we don't want to go through all of this. We could, there's not too many packets here. There's only 166 packets displayed. So we could probably just scroll up and down until we saw the text record. Okay. But again, let's expand our minds and wonder, what if there were thousands or millions of DNS requests in this list, and we wanted to isolate the text records? Again, I want you to play around with filters. Okay, filters. So what we can do here is put dns.query.type equals text. And you see that Wireshark is giving us red, and if we hit enter, nothing will happen. That's because it doesn't want a string here. What it actually wants is a particular decimal ID that refers to that particular kind of record. So we can go back to the best hacking tool once more, and we can go types of DNS records. This will work. Okay, that's not what I'm looking for. Here we go. List of DNS record types. And you can see here's the A record, and it has type ID of 1. So if we put a type ID of 1 in, if we put 1 in here, we're going to see all of the A records, and you can see all the requests for A records. So all we need to do is scroll down here, and again, there are a lot of different types of DNS records that you can request. Obviously, you don't need to know all of these beyond the scope of this discussion, but we just want to go down to text, and we see that its ID is 16. Splendid. So we can just type in 16 here, hit enter, and boom, we see a query for a text record and then the response. And what we're looking for is the contents of that text record. So we want the response, which is down in here. And we see in the answers section, we see text, and we can expand that. And once again, we see the flag down here. Now, you are going to have a little bit of trouble copying this. You can right-click and copy bytes as hex and ASCII dump, and then isolate out the specific flag or whatever. It's going to be a lot easier for you if you just right-click, follow UDP stream, and then you can just copy the flag right out of here. Okay, little trick from me to you. Just a little helpful little trick there. And we submit, and we've solved yet another one. Now we just have one more protocol to talk about here, and it's a good one. Okay, FTP, our good friend FTP. Okay, file transfer protocol, an old, some would say outmoded section, or not section. What am I even saying? Somewhat outmoded method of transferring files over a network. Okay, so you can reveal that. The easiest way is just going to be type in FTP. You can also do TCP port equals 21, TCP.port equals 21. But you're also going to get like the ACKs. You're going to get the TCP handshake, which you can see here with the SYN, ACK, and ACK, and then you're going to get every subsequent ACK. Which is not very. If you just want to see the FTP packets, which I do recommend, just type in FTP right there. Okay, so you can see that FTP is yet another clear text protocol. So once again, I just love clear text protocols, don't you? As a red teamer, as a penetration tester myself, I love clear text protocols. It just warms my heart to see people using such insecure such insecure methods of communication, so that I can finish my work easy for that day and spend the rest of the time beating Dark Souls bosses. Or should I say dying to Dark Souls bosses. So we do see, we can once again see the contents of each of these packets, but once again, Kevin, there's got to be a better way, right? Right click, follow, TCP stream. And right here, we can see the entire FTP session. Well, almost the entire FTP session, but we'll get to that in just a second. And we can see that the user connected to a server, which reported its version as VSFTPD 3.0.3. This is the banner, okay? The user logged in with the name TryHackFTP. The server responded asking for the password. The user typed in this password right here.
A fine addition to my collection.
We love those fine additions to our collection, don't we, folks? We love those credentials. Then they changed directory into the files directory using the CWD, current working directory command. Then they switched to passive mode. You don't need to really know about that. That's beyond the scope of this discussion. And then they used the store, STOR command, to upload a file called secret.txt to the server. Then the server responded, okay, time to send the data. And then the transfer was complete, and that's when the FTP session ends. Okay? Easy peasy. So, in the FTP section, what is the FTP logon password? This right here. Okay? In the FTP section, what is the FTP command used to upload the secret.txt file? And that is STOR. There we go. Now, you might be like, Mr. Streamer, where's the file? Shouldn't the file be in here because we're viewing the entire FTP stream? Not actually the case. So when you run the store command or the put command, anything that uploads files to the server, what's going to happen is that the FTP server is actually going to open a separate communication stream entirely for the file transfer. And once it's open, then the server is going to respond okay to send data. And then the data gets sent over that other communication stream. So our current filter for FTP is not going to review that, is not going to see that file transfer. Instead, the filter you're going to want is FTP data. And you see we have one packet in here, and you can go back and you can say line-based text data, and you can see the flag right here. But once again, Kevin, there is a better way. Right-click, follow TCP stream. This will be very helpful if, for example, someone's transferring a much larger file than just this. But again, outside of the scope of this discussion, this video is already running long. Okay, so let's go ahead and copy this, paste it in right here, and there we go. We have completed yet another day of Advent of Cyber and added some more wrinkles to our brain. And that's just splendid. That's just stupendous. So, I hope you enjoyed this walkthrough of TryHackMe's Advent of Cyber 3, Day 9. And if you liked what you saw here, if you enjoyed it, if you learned, I'd encourage you to check out my presence on other platforms such as twitch.tv, where I do a live stream 3 times a week doing all kinds of offensive cybersecurity shenanigans. I'm a professional red teamer, and I enjoy doing CTFs such as TryHackMe rooms, King of the Hill with viewers, and all kinds of stuff. We get up to all kinds of shenanigans. We have tons of memes, tons of fun. We have a great, rapidly growing community. I'm very proud of it. Go ahead and check it out. Be a part of it. We'd love to have you. And check out my Twitter, And it's also easy to find me on Discord and on email. If you have any Discord, Twitter, email, if you have any questions, comments, threats, bribes, yeah. I hope you're enjoying the rest of Advent. You hope you enjoy the rest of Advent of Cyber. I hope you enjoy the rest of your holiday season. But make sure to finish Advent of Cyber because I'm watching you. Get every single challenge done. Add as many wrinkles to your brain as possible because it's a great opportunity to start your path into the cybersecurity world. Go to bed tonight knowing a little bit more than you did yesterday, and I'll see you again when the stars are right. Stay safe. Get vaccinated. Because I love you, and I wouldn't ever want anything bad to happen to you. Even you, Kevin.